Good morning, everybody. Hopefully you guys are having a good day. If you want to sign in with some green check marks, and if you have any questions, you want to throw those into chat right now from the learning guide from last day, that would be great. And I'd be happy to go over those. If there's no questions, I'll just move on to the lesson 2. But if you guys had anything you didn't know or didn't understand, you could fire those in. There's some check marks pouring in. No, the recording from yesterday isn't up yet. I got it this morning, so we will have it up probably in the next couple hours for sure. I apologize for that, but sometimes we can only do so many things at one time. But it will be up today for sure. I want to mention a couple things about the test, the Unit 2 test. About I think 7 or 8 people have written it yet, so it's almost half of us. I was hoping it would be done for today, and a few of you had talked to me, sent me some messages indicating why you hadn't written it and like issues in that. So if you haven't written it yet and you need to tell me why, that'd be great. If not, I might have to start cracking the whip on a few of you guys here to get you through Unit 2, because we really need to get that out of the way, because we're already on Unit 1 now, and this unit is only 4 lessons long, so we've done this one on Monday, and we'll be looking at another test mid or end of next week as well. So yeah, things are kind of rolling along here. This Unit 1 is really short, so that's just kind of why I wanted to get Unit 2 out of the way so we could move on. Shane has asked a question. Are we doing the learning guide, not the worksheets? And that's a really good question. Yeah, we're just doing the learning guide. If you want some extra practice, those worksheets are there in the assignments, so you're welcome to do them. All the solutions and everything are there. Maybe if you're not understanding a topic or something like that, it's really important that you're honest with yourself. If you are going through the learning guide for a particular section and you're not understanding, or you're finding you're getting a lot of the answers wrong, it's important that you either reach out to me and try to get some help on that, or you spend a little bit more time looking at some of those questions that are in the practice assignments. But yeah, we're just going to go through the learning guide this time. I'm just going to try it and see how it works out for you guys. I'm sure you'll like it better because it's less work, but this unit's a little bit more straightforward as well, so lots of drilling of these ideas isn't quite as necessary. The Unit 2 that we did, there's a lot of variety in the problems. You have all sorts of different shapes, and then you can put different things together, and finding the right angle triangle and the different things. There's a lot of different things you can encounter, so I wanted to kind of expose you to a lot. But this unit, a little bit more straightforward. There's only a few ways to do these problems, so that's kind of where we're at. Hopefully that works. Nobody threw any questions in chat from the learning guide first section. I know you guys are probably working through Unit 2 still, which is kind of my fear. So I really want to get that out of the way. Today we're going to talk about evaluating irrational numbers. So we are going to use our calculators a lot in this unit, and it's not something that we need to like shy away from. You have a calculator. You're going to have to be able to use it. There's a few questions where it says estimate, so that means don't use your calculator, but the majority of them we will. So hopefully you have your calculator, and as I said at the beginning of the course, and I'll say it again, it's very important that you are familiar with your calculator. You don't want to come into the midterm or the test and forget a calculator or not know how to use a particular one. So especially with this stuff that we're doing today, all calculators are different. There's no sort of industry standard of how things need to be entered. So I'm going to go through a couple of these perfect squares and perfect cubes, and we're going to look at those. And then if you're having issues with your calculator, if you can't find the cube root button or the 4th root button on your calculator, what I'm going to get you guys to do is actually write your calculator model into the chat, and then I'm going to go search it online, find a picture of it, and I'll try to make sure everybody knows how to use their calculator, because it's really important for this whole Unit 1. So jumping into the lesson here, you remember when I don't even know what grade you are when you learn your multiplication tables, but your teacher says, you have to know these multiplication tables inside and out and forwards and backwards, and we're kind of at that point again in grade 10, which sounds a little bit weird, but we're going to deal with perfect squares and perfect cubes today, and the better you know these, the easier this unit is. So you just need to be able to recognize them quickly, and it'll make your life so much easier. So we're kind of back to memorizing times tables again. Now, if you don't have all of these memorized right now, that's fine. But you're going to see that they come up again and again and again, and it's important that you kind of know what they are. So we're going to look at this table. You're going to fill it out, and then when you're going through your work for the rest of the unit, you can kind of refer back to it if you don't remember all of these. But we're looking at the first 12 numbers, so we're going from 1 to 12. And all we're doing is we're going to write in the squares of each of these. So if I go 1 squared, I get 1. And if I go 2 squared, I get 4. If I go 3 squared, 9. Then we get 4 squared, 16, 25, 36, 49, 64, 81, 100. Hopefully you got up to there. 11 and 12 come up a lot as well. 121 and 144. All right, so those are our first 12 perfect squares. And it's very important that you know those. You just have to know them. So if you don't have those memorized, it would be worth your while to maybe just practice a little bit to try to get a feel for them, because they're going to come up again and again and again and again. This next step may seem a little bit silly, but we're going to just do it anyways. We're just going to write the square root of all these things, because it's important that you recognize these things under a radical sign, because they're going to just come up a lot. So when you see the square root of 36, or the square root of 49, or the square root of 64, a little red light should go off in your head, and you should think to yourself, that's a perfect square. That's important. For some reason, Mr. Borden told me to remember all of these. So those are our perfect squares from 1 to 12. We're going to encounter those a lot. The next column here is your perfect cubes. So we're going to, if you have a cube, you're going to multiply a number by itself 3 times. So 1 times 1 times 1 is just going to give us 1. And then 2 times 2 times 2 is going to give us 8. And then 3 cubed, 27. Those are the important ones. I'm going to recommend we know up to 6 cubed and memorize those. So instead of going all the way to 12, we'll just go halfway to 6. These ones don't come up quite as often, but they are important. And the numbers get big really quickly because you are cubing them. So 1, 8, 27, 4 cubed is 64, 5 cubed, 125, and 6 cubed is 216. You could continue and fill out these ones if you want. I'm not going to. And the reason, again, is they don't come up as often, and I just want you guys to kind of remember the important ones for these. So these are the ones that are going to appear again and again in all of the questions we do. So those are your perfect cubes. Again, we're just going to write them down with a cube root in front of them, because you should be able to recognize these things as perfect cubes. Is 0 a thing? So Alex, I'm not sure I is negative 0 a thing? You're asking about the negative sign in front of the 0? Is that, yeah, negative 0, perfect. Yeah, I guess, as just kind of an aside, you don't need to write this down. I'll just throw it over here in the margin. So if you think about negative 0, that negative sign could be negative 1 times 0, which is just 0 all over again. Because if you're multiplying anything by 0, you're just going to end up with 0. So it would be uncommon for us to write negative 0. The equivalent would be negative 1 times 0. But I don't know if that really makes sense. Should we put it for question 9 on page 2 of the learning guide? How about at the end when I go to the learning guide, you remind me of your question, Alex, and I'll go back to it and hopefully I can answer it for you. Because I'm not familiar with that right yet. All right. I'm going to go through the perfect fourths or the fourth power of these things, and then I want to make sure everybody's kind of comfortable with their calculator before we move on. So again, if we think of 1 to the fourth power, it's 1 times 1 times 1 times 1. So that's just going to be 1. If we think of 2 to the fourth power, 2 times 2 is 4, times 2 again is 8, times 2 is going to give us 16, 81, and 256. Now, these ones aren't as common. I'm going to admit that I don't really have these memorized. Maybe the like 116 and 81, but we don't deal with a lot of perfect fourths. So yeah, just kind of here for reference sake. I'm going to write them down like we did, and then we can have a look at some examples. So we're going to take the fourth root. I can put a little 4 in front of 1, a little 4 in front of 16, 81, and 256. So again, because these numbers get so big so fast, all this empty space here, generally we don't run into those numbers. I'm not going to say they never happen, just not as common. So these are the ones you just should know in the table here. These are the ones that are going to make your life easier, going to make everything just work a little faster and smoother. So there you go. Now, the calculator issue. It's important that we know how to use them. So maybe before we even get into the next section, the few examples we have here, maybe we can just make sure everybody knows how to use their calculator. And I can't stress this enough, don't be shy. If you're having issues, make sure you say something, we can figure it out, and then you'll be able to do the work for the rest of the unit. So maybe just as an example, maybe let's everyone see if they can find the third root of 64. So if you plug into your calculator to figure out the third root of 64, I want to just make sure everyone's kind of on the same page. Taylor, I don't know how to do the fourth root. Okay, after we do the third root of 64, let's see if we can do the fourth root of 256. And see how we end up with that. So I just want to kind of put in those into our calculators. Jade, that's going to be tricky. The TI-83 Plus is going to, you're going to have to put it in as a fraction, and it won't make a lot of sense right now, but when we get into the unit number 3, it should make sense. So what I want you to do is figure out how to use your calculator to get the cubed root, or the third root of 64, which should give us 4. So you want to end up with 4 there, and then the fourth root of 256 should also be 4. So both equal 4. Yep, Abby's on it. How about if you, Jade, I'll get to yours in a second because I have my TI-83 on this computer. If you're having an issue, just want to throw up a little red X next to your name in chat, and then maybe we can kind of just take a second to make sure everybody's comfortable with their calculators. So first one is Jade. I'm going to flip my screen around here. and see if I can find my TI-83. I don't know if this is gonna work. Perfect. All right, Jade. Now, you'll notice on the Texas Instrument calculator, there is no x to the y or little cube root. So Jade, what you're gonna have to do is use the little hat button here. And it's gonna be really weird. So Jade, if you have your programmable calculator, well, the first example we were doing was, the cube root of 64. So what you're gonna have to do is go, see if I can remember this, 64. Oh, now mine's not gonna work, oh no. So you're gonna go 64 and then use the little hat, and then you're gonna have to start a bracket and then go 1 divided by 4. So I'm gonna write that down for you, Jade. See if I can find a spot here. So Jade, you're gonna go 64, the little hat, then the bracket, the 1 divided by 4, then close your bracket, and then hit the enter sign. So that's how you're gonna find the, either or. You can do if you want the third root, you're gonna have to go 1 divided by 3. And if you want the fourth root, so we're going to do the 256 hat, 1 divided by 4, and then enter equals. And those should both be 4. Is anybody else having issue with their calculator? The TI-83 is going to be a tricky one because it doesn't have that button. There's a couple models of the Casio calculators that don't have them either, so we're going to have to figure something out. If you just want to put the model of your calculator into chat, I can just do a quick search. We'll find it. We'll figure out what the button looks like. TI-30XA. That's a pretty common one, actually. Let's see if I can find it. TI-30XA. Is it the new one or the old one? So this guy, it's not the greatest image of that. Let's see if I can get a better one. It looks old. It's probably this guy here. Alex, the calculator on your phone is not going to work because you can't use it during your exams. So these buttons aren't great. You have it right here. If you have this TI-30XA, you have to hit the second function. So you'd probably put in if you go 4, second, y to the x, and then put in the 256 and then hit equals. Or it might be backwards. You might have to go 256 and then second x or y to the x, and then hit the 4 and then hit enter. So you're gonna either have to do, I think these ones are backwards. So maybe try the 256 and then second y to the x and then 4 and then enter. I think most things in these guys are backwards. Try it a few ways until you kind of end up where you need to be. That equals 4. We did it. Excellent. So like I said, it's kind of about learning how to use your calculator because they're all different. The other one equals 1. Haley, what type of calculator do you have? Because the little hat button isn't necessarily the one we want to use. Hopefully we can find the right button. Casio FX991. Yeah, for sure. I'll bring it up here, make sure we're using the right button. And there's a few ways to do these. Casio FX991 MS. Probably this one. This is a calculator I really liked using when I was in school. Yeah, you have the hat there, Abby. And then to get to what you need, you got to go second function. And I think yours is going to be doing things forward. So you're going to do like for second function hat to get the little guy up here above it, the yellow one, and then 256, and then enter, and that should give us 4. And yeah, that's right then, Abby, you're doing okay. Haley, I have a feeling yours would be the same as what I just showed. Most Casio should be the same, but I can bring it up. So the FX300 ES Plus. Usually manufacturers will keep their calculators the same. They just get older and newer. That's not big enough for me to see. Let's see if I can find a bigger one. Nope. Nope. I'm thinking it's the same button up here. The X squared looks like it has the X to the Y above it. Yeah, Y to the X. So you might have to go shift Y to the X. If yours looks like that, I guess they have different ages and different colors, but they should be relatively the same. It's a pretty fancy calculator. It's too bad I can't get a big image of it. I'm gonna guess it's this button here. If you have this calculator, you have to hit the shift key and then go to that. And I have a feeling that one will be forward as well. So you're gonna go like 4, shift X to the Y, and then the 256, and then hit the equal sign. Now, hopefully you've had a chance to ask about your calculator. Again, don't be shy. And using your phone's not gonna work. And even the TI-83, I don't know if they've changed the rules recently, but the TI-83, because it's a programmable calculator, you might not be able to use it on the provincial exam. I will double check that and I'll get back to you tomorrow for sure on that one. I'd hate for you to get started with it and then not be able to use it. The rule is no programmable calculators, or it used to be. I don't know if they've changed it recently. I'll verify that for you, just so we know. Nobody else has a question about a calculator they want to put in there? I see a couple of people typing. I'll give you a second. I'm just gonna maybe go back to my lesson and we'll just continue on. If something comes up along the way, why no programmable and what is programming a calculator for? Those are excellent questions. Basically, if you have a TI-83, like this guy, the big graphing calculators, you can program text into them, and you can program them to do calculations for you. So you can like write a program for, say, like the Pythagorean theorem. Programs exist on these guys. So you put in A and B and it gives you C, or you put in A and C and it gives you B. So you can program them to do things for you. So basically the math people in the province don't want you to be able to program these to do the math for you. They want you to do it on your own. Are Stables calculator okay for the exams? Stables calculators are fantastic for the exams. They're inexpensive. They do everything you want them to do. They're perfect, really. And they're the only thing about this one that's different from something like this, which is just a scientific one. This little guy, the Casio I have, or Sharp, sorry, you can't program anything into it. But the big TI-83s you can. So hopefully that answers your question, Alex. Are Stables ones good? Yes. What is that type that won't be permitted so I know not to buy it? Damon, it's if you're buying a calculator, if it's less than like $30, I mean, you can get a scientific calculator for like less than $5 if you find a good deal on one. The TI-83s, the programmable ones, the big guy here, these are graphing calculators, and they're usually about like, $80 to $100 depending on the model you buy. So don't buy a big graphing calculator. They'll be sold as graphing calculators. That's kind of the big draw there. Any kind of smaller calculator with a pretty basic window, these are the scientific ones. So these are the ones that you kind of want to get. And there's lots out there. If you're unsure, you can send me a message like, hey, Mr. Borden, this is what I bought. Is it good? Or can I use it? And I can reply to that for sure. Isn't doing the math for you what a calculator is for? Yes, Alex, that's exactly what it's for. And you'd think if you are smart enough to go online and get a program for your calculator that makes your calculator do things for you, then why not, right? It's kind of a funny place we're in right now in education, just in general, where we have all this information and we can, for instance, the unit we're doing is like irrational numbers and whole numbers and natural numbers. If you can just type that into a computer and it can spit what it is out at you, is it really important that you know the definition? It's kind of one of these things where curriculum and education is just trying to catch up to where society is. If you're working in the workforce and you can just search for some definition, is it important that you know it? Probably not. You can just search for it. So that's kind of where we're at, kind of at a bit of a turning point, and things are a bit different. I don't know. I don't make these decisions. I just try to get the information in your heads so we can be successful. So let's jump into the rest of this. Start a petition. Damon, you started. I'll sign it. I promise you that. All right. So the ones that I wrote in here, these are the kind of ones we need to memorize. And again, if you don't have them memorized, it's not going to be the end of the world. I don't want you to sit at home and drill them into your head for the next 3 days. They're just going to come up a lot. You're going to see them a lot, and the faster you're able to recognize them, the better off you're going to be. So that's just kind of what it's all about. Question 1a, which two perfect squares, or in the ones on the bottom, have a little bit higher exponents, so third and fourth, do the following fall between? Evaluate the square root of the number by estimating. So we're going to try this without our calculators and see how we do. So I'll do the first one to kind of give you a little bit of an idea of what I'm talking about, and then maybe you guys can see if you can get through the next few. Feel free to use the table up above. So the first example we have here is the square root of 13. We know that's not a perfect square, and it's not on our table as one of the perfect squares, so the answer is going to be a decimal. That's fine, we just want to estimate it. So if I think about 13, what two perfect squares does it fall between? And I know that the square root of 9 is a perfect square, and then the square root of 16 is a perfect square. So I know that the square root of 13 is going to fall somewhere between those two. I know the square root of 9 is going to give me 3, and the square root of 16 is going to give me 4. And is the 13 closer to the 9? Well, it's about 4 away from 9, and then 13 to 16 is about 3 away from the 4. So it's a little bit closer to the 4 end of things. So if I were to estimate it, I would maybe go like 3.7. That'd be maybe an estimate, a guess that I'd give it, because I know it's somewhere between the 3 and the 4, and it's a little bit closer to the this side of things. So it's probably going to be in here somewhere. 3.7 would be my guess. Now, if I were to take my calculator and actually figure out what the square root of 13 is, because I actually don't know that, I would end up, just to see how close my guess was, it's 3.6055. So I guessed 3.7, it was 3.6. I'm pretty happy with that. That's a pretty good guess as an estimate as far as that goes. So the next one, the square root of 28, where are the perfect squares on either side of that? So what's just the perfect square below 28, and what's the perfect square above 28? This is why it's important to know our perfect squares. So 28 is kind of close to 25, so I could have the square root of 25, and then the square root of 36 would be the kind of the other one. So Taylor, you were on it. So if we had to estimate that, I'd say that the 28 is really close to 25. It's a long ways away from the 36. So it's probably going to be really close to 5, because I know the square root of 25 is 5, and 36 is the 6. So where is it going to land in there? If I were to guess, I'd say probably like 5 point maybe 1 or 2. Taylor says 5.3. I don't know. What is it? Let's figure it out. Again, just to see how close our estimate was. Now, there's going to be some sections on the provincial exam where it was 5.29. So 5.3 was the pretty good guess. 5.29 was the actual value. There's sections on the provincial exam which will ask you to estimate, not using a calculator. So actually doing this estimation is important, because you literally, for the first, I think it's 20 questions on your provincial exam, maybe it's less, maybe 10, you have to keep your calculator on the ground, and then you have like 30 minutes to complete that section, and then after that 30 minutes is up, they'll say, okay, you can pick up your calculators, and then the invigilators will come around and take away your no calculator booklets, so you have like 30 minutes to get that done. You can move on to the other part of the exam, but you have to kind of do that section first, and then you can use your calculator for the rest of it. So not using your calculator is important, especially for these types of questions. The next one, we have the square root of negative 98, or negative square root 98. I'm just gonna write in something here to hopefully kind of clarify this. If I wanted to break this up as negative 1 times the square root of 98, then I can think about just kind of ignoring this negative 1 and then just dealing with the 98. Ab, you're asking a great question here. So I guess I'd need to have square roots memorized for that section. If you aren't good at memorizing the square roots, but you can do multiplication in your head, you're kind of there, right? So if you don't know what the square root of 36 is, but if you can just write down on the top of your test, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And when I have students do this section in the regular sort of classroom, I always tell them, as soon as they get their test, write down your perfect squares at the top of it, from 1 to at least 10. If you want, you can do from all the way to 12 or 13. Just write them down on the top page of your test, and then they're there. You can just refer back to them because they come up a lot. So Taylor's a step ahead of me. I'm going slow today. Taylor says it's around 9.8. So maybe we'll figure it out. So I know 98 is really close to which two numbers? So I have the square root of which two? So it's close to 100. It's just under the 100. And then I have 81. So this is 9, and that's 10. It's going to fall in somewhere there. Where? It's kind of close to the 100, so you're going to go with 9.8 or something like that. I think I'm on board with that. So I'll go maybe approximately 9.8 or something like that. I like that. Now this 315 kind of ratchets things up a notch here. We've only gone on our perfect squares up to 12 squared is 144, 13 squared. So we don't have anything in the 300s. So we're going to have to do it is probably use our calculator, figure out the squares, and then we can kind of work backwards. I know I said estimate, but it's important that you kind of understand how to do this. So Taylor's asking a question about why is there a minus if you can't just put in 98 squared? So why isn't the number a negative answer? That's a really good question. When you can't take the square root of a negative number, because if you think about what a square root means, it's what two numbers multiplied them by themselves give us that value. So if I had like 2, positive 2 times positive 2 gives me 4. But I can't have one being positive and one being negative. So I can never take the square root of a negative value because they have to be it's the same number multiplied by itself. So if one's negative and one's positive, then that is by definition not a square root because they're not the same thing. Negative and positive, if I drew it on a number line, they'd be at different spots. So technically speaking, when you take the square root of a number, you could have negative 2 and negative 2 to give us the positive 4, or you could have positive 2. So sometimes when you see square roots and you get answers, if you saw like the square root of 36, sometimes people will write plus or minus 6 as an answer with the plus and the minus, because you could technically have the minus 6 times the minus 6 gives us the 36. So that is kind of where we're at. You'll notice down here, which I think a few of you have, we have the cube root of negative 1, and the cube root by definition is something multiplied by itself 3 times. So if you think about negative 1 times negative 1 times negative 1, that is a number that's multiplied by itself 3 times. So we can take the cube root of a negative, but we cannot take the cube root of a negative. Or sorry, we can take the cube root of a negative, but we can't take the square root of a negative because with a square root, they have to be the same. But with a cube root, they can be, because there's 3 of them, they can be negative. We'll get into it a little bit later, a little bit more in depth. What I can tell you for this one up here is 17 squared is the square root of 289. And of course, you'd have to just plug these into your calculator. 18 squared gives us 324. So what you'd have to do is just kind of, keep squaring numbers until you got to the 315. So this is 289 is a long ways away from 315. 324 is perhaps a little bit closer. So we're going to be somewhere in the 17 point. I don't know. Somebody put something in chat, I believe. 17 point, maybe 7 as a good estimate for that. If you had 17.8 or 6 or 9, those would all be fine. There's nothing wrong with that. And they're estimates, right? So if you're, in the ballpark, off by maybe 2 or 3 tenths, that's it. That's all you need to do. Nobody's gonna harp on you for your estimate being not close enough to the real value, unless it was wrong. All right, we need to mosey on through the rest of this. This next one's the cube root of 81. So 81 is a perfect square. The square root of 81 gives us 9, but we're talking about the cube root. So just like when we cube a number, it's a number multiplied by itself 3 times is cubed, and then the cube root is what number multiplied by itself 3 times gives us this value. So if you look at your table, you'll see that 81 is between the cube root of 64 and the cube root of 125. So we're in between, the cube root of 64 is 4 and 5. Which one are we closer to? We're about 20 away from the 64 and we're about 40 away from the 125. So we're gonna maybe go like 4.2, something in there. I'd be happy with that. Cube root of negative 1 comes back to this idea of what number multiplied by itself 3 times gives us that thing. So the cube root of negative 1 is negative 1. That's an exact value. There's no decimal there. We don't have to estimate that. That just was there to introduce the idea of the negative sign being there. So hopefully we don't get tricked by that one. The next one is the fourth root of 50. Looking at our table from above, we see that we have the two values here. So we have the 4th root of 16 and the 4th root of 81. And the 4th root of 16 is going to give us 2, and the 4th root of 81 is going to give us 3. 50 is maybe a bit closer to the 81. So if I were going to estimate that, I would probably say 2.6 or 2.7, something along those lines. And then the last one, the cube root of negative 72. Again, we just look at our cube roots. And I can just throw the negative sign in here. If you think about it in terms of a number line, I'm just on the other side of the number line. So this is between 64 and negative 125. So we're midway between 4 and 5. Negative 4, I should say, negative 5. What are we closer to? Well, we're about 8 away from the 64. So we're really close to the 4. So I'd probably go with maybe 4.1 or 4.2 as an approximation, and just making sure to put in the negative there. So those are just estimates, not exact values. You don't have to have the exact number in for those. So just do your best to find the perfect square on either side or the perfect cube on either side, and just kind of go from there. That is kind of just an introduction to this stuff. So the back page is using your calculator. So I'm just going to scroll down. And these are, I guess number 3 is calculator. These questions for number 2 are just trying to figure out if these are equivalent. So when we deal with order of operations, bed mass, technically speaking, a radical sign is treated as the same as an exponent. So the radical sign would be equivalent to an exponent in our order of operations. And we'll look at why that is in the next unit 3. But for now, you're just gonna have to trust me. Put a little trust in me. You can kind of deal with it as a bracket. So if I add 81 and 16 together, I should end up with 97. And if I plug that into my calculator, the square root of 97, plug her in there, what do you get? You should end up with 9.84. It's gonna keep going forever. So that's an approximation for the square root of 97. Now if we do them separately, if we add the square root of 81 to the square root of 16, we know the square root of 81 is 9, and we know the square root of 16 is 4. 9 plus 4 is 13. So are these two things equal? No, they are not equal to one another. So that means if I'm doing a problem and I see that I'm adding radicals either underneath or on the outside, even though they're the exact same numbers, mathematically speaking, if we're following our order of operations, we're not going to end up with the same value. So that hopefully is something that kind of sinks into your brain a little bit, and you're able to kind of figure that out. The next question's multiplication. How did I add the first one? 81 and 16 together. 8 and 1 is 9, and 6 and the 1 is 7, 97. So I have to do everything inside the brackets first, or inside the radical. So I'm going to do my addition first. And then this one I have to do these separately. Hopefully that makes a little sense. Let's see if we can do it again on this one. Because I have the square root sign, I'm going to kind of treat it like a bracket. I'm going to multiply the 81 and the 16 together in my calculator and see what I end up with. In this case, I have the square root of 1,296. With the second one, I'm going to end up with just 9 times 4. So what is the square root of 1,296? Somebody can plug that into their calculator for me. I can do the 9 times 4 is 36. What do we think? What was the square root of 1,296? Haley and her blazing fast calculator skills are telling me that these things are the same. All right, so what is the lesson to be learned here? Well, when you're adding under your radical sign, like the first example, A, we can't take these things to be the same, but if we're multiplying, we can break them apart and do them separately. So we're going to use this property a little bit next day. We'll look at another example here. The second one, C and D are just subtraction and then another multiplication type one. So if I take 100 minus 4, I'm going to end up with the square root of 96. And then the square root of 100 is 10, and I'm going to subtract the square root of 4 is 2. So I end up with 8. The square root of 96 is not 8. That should be 9.797. So again, when I'm subtracting, these things are not equal. What about with D? Are they going to work out to be the same? 100 times 4 is the square root of 400. You're going to get 10 times 2. Square root of 400 is 20, and 10 times 2 gives me 20. So these things are equal. So this is just a basic property of multiplication that we encounter with the radical signs here. So if we're multiplying or dividing under the radical sign, we can break them into two separate things. And then if we're adding or subtracting under the multiplication sign, we can't break them into two separate things. The order of multiplication doesn't matter, whereas subtraction does. So if you think about if I go 10 minus 6 gives me 4, if I go 6 minus 10, I get negative 4. So those are two different answers. But if I'm multiplying, it doesn't matter, 6 times 4 or 4 times 6. They're going to give me the same thing. So it's kind of a basic math principle, and I'm glad you find it interesting, Abby. It's sometimes hard to find interesting things in math for young people your ages. Evaluate the following to the nearest hundredth if necessary. All we're going to do here is use our calculator. Haley likes it too. I'm glad I brought a little bit of joy to your math lesson for today. We're literally going to use our calculator. This is kind of bringing in the BEDMAS idea. We're going to treat a radical sign as though it's an exponent in our BEDMAS. So if it helps, the first one here, you can write it as this, -2 times the square root of 34. So until you've seen a lot of these, if you're not kind of comfortable just doing the root 34 and then multiplying by the 2, if you want to break it up into two different things with the brackets, that's fine. So what is that going to give me? I don't know what the square root of 34 is, so I'm going to plug it into my calculator. Square root 34. That's going to give me 5.83. I'm going to write this down as 2 steps. If you want to do it as 1 step in your calculator, that's completely fine. And then I'm going to multiply that by the -2. So I'm going to end up with -11 and the question asks for the nearest hundredth, so that's 2 decimal places, 11.66. Square root of 34, all right. The next one, same sort of process. You can, if you're really good with your calculator, you can plug it all in one step, which kind of lends a lot of places for mistakes, or you can do it in 2. So what I'm going to do is I'm going to figure out what the top is first, and then I'm going to figure out the bottom, and then I'm going to divide them. So I'm going to do it in 2 steps. The way I'm going to write it into my calculator would be the square root of 12. I'm going to hit equals, and then I'm going to multiply by 10. And the top is going to give me 34.641. And then same thing on the bottom. I'm going to take the square root of 18, hit equals, and then I'm going to multiply that answer by 5, and I get 21.213. Now, I know that the question is asking for an answer to the 100th, so I'm going to just keep my decimal places to the thousandths, or one additional one. So when I round, it's not going to have any effect on my answer. I'm going to take that 34.641 and then divide it by the 21.213, and I end up with 1.63. Almost out of time here. I have 2 more. I'd really like to get these done. I'll just do these quick. If you have a question about what I've done, fire away. So square root of 21 on the top. 4.58257. And then on the bottom, I'm going to have the square root of 7 times 3, which gives me 7.937. And then I'm going to subtract the square root of 8, and that's going to give me 2.828. Now, I divided by 21.213, but it's 21.251. Did I 5 root 18? 21.213. I get the same thing on the bottom, Alex. You might have maybe punched something in. Can anybody else verify for letter B here? If I was on the right track. 21.215. I get 21.2132034. Oh, just my poor writing. There we go. Sorry. I get going fast, things get messy. All right, now I'm going to do the subtraction on the bottom, and then I can do the division after. So 4.58257, 7.937, 828. End up with 0.896. So this one's perhaps a bit tricky because it's just a rounding sort of question. We get 89696. I need to round to the hundredths, so I'm going to round the 9 up, so that becomes 10. So I should end up with 0.90. It's a bit of a rounding question there. And the last one's cube roots. So making sure you know how to use a cube root on your calculator. I'm going to take the cube root of 72, which is going to be a decimal. So that's going to be 4.16. I'm going to have 2 times the cube root of 51. I can do this in 2 steps as well. 3.708. You carry the 4.16 down. I'm going to take the 2 times the 3.708. And end up with negative 3.26. How did I put that into my calculator? My calculator, because I can put things in brackets, is going to be a little bit different than your calculators. You'll likely have to do each calculation separately. So you'd probably have to do the cube root of 72 first. Notice how I found the two cube roots first. And then I did the multiplication between these two things. And then I did the subtraction. So just following my BEDMAS, where any sort of radicals end up as being exponents. I encourage you to try those in order to get them right in your calculator. Again, some of the practice we're going to do today is the same as this stuff. So you guys did the number line stuff. Today for homework, I'd like you to do the estimating radicals. This is from the learning guide. And evaluating irrational numbers sections. And that takes you to the simplifying radicals. So we should be on pages 3 and 4, and then a couple questions on page 5. So again, for homework tonight, evaluating irrationals, and then above that was estimating radicals. Kind of the stuff we were doing. So that's where I want to leave you. Taylor's asking a question about 7.41. Oh, for 2 times the 3.708? $7.416. I get the same thing. Maybe you just didn't carry enough decimals in your calculation, Taylor. So just be careful about that. I'm going to leave you with that for now. Hopefully you guys are still plugging along with Unit 1. There is in the course this Save the Penguins game, and it asks you in the actual worksheets about the Save the Penguins game, so make sure you give that a try. It's just a fun thing to practice your perfect squares and your cubes and things like that. So have a look at it. It's kind of fun. And that's where I'll leave you for today. So I hope you guys have a good afternoon. If you have any questions, fire me a message in Moodle, and we'll see you tomorrow.